Let's look at how we would solve radical equations containing the nth root. I've copied this from your textbook. It says, if necessary, we want to arrange the terms so that one radical is isolated on one side of the equation. And then whatever root that radical is to, we're going to raise both sides of the equation to that root. And we are going to solve the equation that's left. It's very important, especially when you're solving with square roots, that you check your solutions, because a lot of times when you square the problem, it will throw out an extraneous solution. So it's going to be very, very important that we check all solutions with these. All right, so what does these results or these rules mean? We want the radical part by itself. We start off with an easier problem with number 12. You can see that the radical is on one side by itself. It is a square root, so the opposite of taking the square root is we're going to square both sides. That's what the textbook means by taking it to the nth power to eliminate the root. Because when you square this square root, you only get the base. When you cube a cube root, you get what's left up under the radical. On the right side, x to the second is x squared. So we're going to solve the equation. How do we solve equations to the second power? We're going to get them set equal to 0. So moving negative 8x over to this side, the opposite of subtracting 8x is we're adding 8x to both sides. I have a positive 20, so if I want to move it to the other side, I'm going to subtract it. So we're getting it set equal to 0 so that we can factor. This is an easy trinomial, does not have a greatest common factor. X squared breaks down into x and x. With our easy trinomials, if the third term is negative, it's plus minus, and we're looking for two numbers that multiplies together to give me negative 20, but adds together to give me positive 8. Can you think of two numbers? What about a positive 10 and a negative 2? When I multiply those together, I get negative 20. When I add them, I get positive 8. So that is the correct factorization. And now I'm going to set each of those factored parts equal to 0. So x equals 2 and x equals negative 10 potentially. Remember, especially in this section, you have to check all of your solutions. All right, so let's check our first solution of 2. I'm going to start off with my original problem. We get the square root of 20 minus 8 times 2 equals 2. So 20 minus 16. And we get the square root of 4. And we're just looking for the principal square root, which is the positive. And it does give me 2. So 10 is a good answer. When I go to plug in negative 10, though, to check this answer, and I'm plugging it into the original equation, I get 20 minus 8 times negative 10 equals x, and again, we're setting x equal to negative 10 in this problem to check it. I can't square something and get a negative number. So while you're checking these, if you have a negative number set equal to your square root, that is not possible. So I'm going to have to throw negative 10 away. That is not a good answer. The only answer to this problem is x equals 2. All right, let's look at 14. 14, we start off, we want the radical by itself. It is. But there's an added step here because when I go to get rid of the radical, I'm going to square both sides. One of the most common mistakes happens over here on the right side where students square the x and they square the 2. But x minus 2 squared means x minus 2 multiplied by x minus 2. I have a binomial multiplied by a binomial, and I'm going to have to full that out. So my first terms would be x times x. I get x squared. My outside terms are x times negative 2, so I get negative 2x. My inside terms are here. I also get negative 2x. In my last term, negative 2 times negative 2, I get positive 4. So I'm going to color code that for you so you see where those numbers come from. So if I add that together, negative 2x plus a negative 2x gives me negative 4x plus 4. And on the left side, when I square the square root, I'm just getting that base. So that part is easy. So once we get rid of the radical signs, once we have folded the binomial, we want to get everything set equal to 0. So I'm going to subtract x from both sides, and I'm going to subtract 10. That's going to give me the 0 on the left side, and let's combine our like terms. Negative 4 and a negative 1 is negative 5. Positive 4 and negative 10 is negative 6. It works out to be this beautiful little trinomial that is factorable. Be careful when you factor. You see 6 and you see 5 and you think of the factors 2 and 3. But remember, my signs have to be, in this case, a plus minus. And so the correct factorization for two numbers that multiply together to give you negative 6, but add together to give you negative 5 would be negative 6 and positive 1. So be careful with your factoring. Don't get in a hurry. If we set these binomials equal to 0 to come up with our two potential answers, we come up with 6, and we also come up with negative 1. So let's check them real quick. We must check all proposed answers here. So I'm taking the original problem. I'm going to start off with my first answer of 6. It's x plus 10, so that's 6 plus 10 equals x minus 2. And I get the square root of 16 is 4, so that checks. And so this first answer, x equals 6, is a good answer. If I plug in the last one, and if I show that step, we got negative 1. I'm going to plug negative 1 in, and I get negative 1 plus 10. Taking the square root of that equals negative 1 minus 2. And I get the square root of positive 9 is equal to negative 3. A square root cannot be equal to the negative, so we're going to have to say that is not a good answer. We're going to throw negative 1 away, and the only answer that we have here is positive 6. You must check all proposed solutions. If you thought that one was fun, you're going to love the next one. Number 18, we're going to continue working some of these. All right, so we see here that our radical is not by itself, and if at all possible, we want to try to get it by itself. So what we're going to do is we're going to move this radical to the other side. Since it's a minus, to move it to the other side, I'm going to add the square root of x plus 11. Those are going to cancel out. I have x equals 1 plus the square root of x plus 11. Is there a way that I could get the radical part by itself? I could take this 1 to the other side, and since it's positive, I would subtract it. That's going to get it to cancel out. And I did all that work just to get the radical by itself. So what's the next step after you get the radical by itself? We're going to square both sides. Remember, I must FOIL a binomial. I can't just square the first and the last term because those middle terms are going to double. So when I FOIL that, I get x squared minus 1x minus 1x plus 1. And when I square a square root, I just get the base. So combining like terms on the left side, negative 1 and negative 1 is negative 2x. Now we're going to set everything equal to 0. So moving positive x to the other side, we're going to subtract x. That gives me x squared minus 3x plus 1 equals 11. And now I'm going to subtract 11 from both sides, and I get x squared minus 3x minus 10. This is an easy trinomial that's factorable. X squared is x times x. My signs are plus minus, and I'm looking for two numbers that multiplies together to give me my last term of negative 10, but adds together to give me my middle term of minus 3. So if we factored that, that would be 5 has to be negative, and a 2 has to be positive. So if we multiply those together, we get negative 10. If I add those together, I get minus 3x. So let's set them equal to 0. My two potential answers are negative 2 and positive 5. So if we plug negative 2 into our original equation, let's see what we get. Negative 2 minus the square root of negative 2 plus 11. I get negative 2 minus the square root of 11 minus 2, which is 9. And I get negative 2 minus the square root of 9 is 3. Negative 2 minus 3 is negative 5, but that does not equal negative 1. So that tells me that 2 gave me a false solution. I can't use negative 2 as an answer. So let's plug in 5. We get 5 minus the square root of 5 plus 11 equals 1. So 5 minus the square root is 16. That's 5 minus 4. And we see that we get a true statement. So the answer that I use here is x equals 5. All right, so let me erase some of my checking so I have room for this next problem. Yes, it does get even more fun trying to erase. The fun part with number 24 is that there's no way to put a radical by itself on one side of the equation. So what we want to do in a problem like this is we want to actually put one radical on the left and one radical on the right. So since this is subtraction, let's add the square root of x minus 3 to each side. That's going to cancel out on the left. I get the square root of x plus 5. equals 2 plus the square root of x minus 3. So let me go back and just make that comment one more time. If you've got two radicals on the same side of the equation, what you want to do is separate it, put one on the left side of the equation and one on the right side of the equation. And now we're going to get rid of the radicals. It's a square root, so I'm going to square both sides. The left side ends up being a lot easier. When I square the square root, I just get what's up under the radical. But I'm going to write this out the long way. This is a binomial in which I'm having to multiply, so I'm going to have to do the full method on this one. Looks like I'm going to run out of room here too. So if I multiply my first terms together, 2 times 2 is 4. When I take a number and I multiply by a square root, we're just going to put that together. So that's plus 2 square root of x minus 3. That's my outside terms. When I move to my inside terms, again, I have 2 times this square root. So I'm just going to put those together. And the last terms here, we're taking the square root of x minus 3 and we're multiplying by the square root of x minus 3. Well, you're squaring the square root of x minus 3. So when you square the square root, you're just going to get that base. Now this looks kind of complicated, but what we're going to do is we're just going to clean it up as much as possible. So I have 4 and I have a negative 3, so I can add that together, and I get 1. These are like terms. If I was adding 2x and a 2x, we add the numbers in front. That's exactly what I'm going to do here. 2 plus 2 is 4. I keep the same radical, just like it is. So I've added these two together, and I still have a positive x. Well, when I take this x and I try to move it to the other side, either x you try to move, they're going to cancel out. Remember, if I have the same thing on both sides of the equation, they're going to cancel out. If I try to move the 1 over, just trying to isolate the variable, I get 4 equals 4 times the square root of x minus 3. This means 4 times the square root of x minus 3. I can divide both sides by 4. That's going to cancel out. 1 equals the square root of x minus 3. I did all that just to get the radical by itself. So now let's square both sides. So 1 squared would be 1. When I square the square root of that, I get x minus 3. And when I solve for x, I'm going to add 3 to both sides, and I get x equals 4. If you plug 4 back in, and I'm going to check it over here because I ran out of room, I get the square root of 4 plus 5, which is the square root of 9, minus the square root of 4 minus 3, which is 2. So I get 3 minus 1 is 2, and that does check. So x equals 4 is going to be a good answer. And it's my only answer for this problem. That's sort of a tough problem, so I wanted to work one more. So again, if you need to pause the video at any time, you can, but I'm on a race to have a little bit more room to work this problem. This is very similar to that problem that we just worked, in that I've got a radical that's on both sides of the equation. So what I want to do is I want to take one of the radicals to the other side. I always, if I have one that's negative, I'm going to take that one to the other side. So if I'm subtracting the square root of x minus 2 and I want to move it to the other side, I'm going to add it. And then once you get one radical on the left, one radical on the right, you're going to square both sides. We'll start with the left side. That's the easiest part. When I square the square root, we get that base. And on the right side, we're going to write it out. I'm going to have to actually FOIL that. So my first terms will be 1 times 1. The outside terms are 1 times the square root of x minus 2. That just gives me 1 times the square root of x minus 2. The inside terms, I also get 1 times the square root of x minus 2. And my last terms, the square root of x minus 2 times the square root of x minus 2, I'm just going to get what's up under the radical. So let's clean it up a little bit. These are like terms, so I'm going to add the numbers in front. 1 plus 1 is 2. A negative 2 added together with a positive 1 gives me negative 1. Let's subtract x from both sides. You could do these in either order. Doesn't really matter. I'm going to add 1 to both sides. So I get x minus 2 equals 2 times the square root of x minus 2. I did all that work. And in previous problems, I was able to divide by the 2, but I can't do that in this problem because that x minus 2 is an expression. So the only option that I have is to square it a second time. And remember, I'm squaring a binomial here, so I'm actually going to FOIL that. So I'm taking a shortcut since I'm running out of room. When you square a binomial, you're going to get the middle terms, negative 2x plus a negative 2x. That's where the negative 4x comes from. And look on the right side. I'm going to square this 2. So when I square the 2, I get 4. And then when I square the square root of x minus 2, I just get what's up under the radical. So we get x squared minus 4x plus 4 equals 4x minus 8, distributing that out. So we want to get everything set equal to 0, so I'm going to subtract 4x from both sides. And I'm going to add 8. So we get x squared minus 8x plus 12 equals 0, which is an easy trinomial that's factored into x minus 6, x minus 2. So my two potential answers are 6 and 2. 6 is going to work in that problem if you plug it back in. 2 is not. It gives you a statement that is not true. If you go back and you try to plug in the negative 2 into this right here, you get 2 times 2 is 4. 4 minus 3 is 1. The square root of 1 is 1. So we get 1 minus, and again I'm plugging in the 2. We get 1 minus the square root of 2 minus 2, which is 0. Let me double check my answers here. Actually, that does work. So 1 minus 0 gives me 1, so the square root of 2 works. And if you, 2 works. And if you go back and you check 6, 6 is also going to give you a true statement. So this is a case where both of them actually are good answers.